All good? All good. Great. Well, I'm going to introduce myself because I'm your next speaker. Building iceperf.com. I've already given this talk a couple of times, and we keep adding stuff that we want to do, so I thought it would be a really great opportunity to talk to a wider audience here about iceperf.com. I've already seen something that's wrong. Iceperf, ice should be capitals. A little bit about me, if you don't know already. So I'm the founder of Everycast Labs and NimbleApe, and I'm the creator of ComCon. I was the first Google developer expert in WebRTC. Unfortunately, I'm no longer a Google developer expert just because of the time involved. I love Lego, that should really say I loved Lego before I had kids, and now I don't have time to play with Lego and make Lego. I love real-time web, real-time media. I love developing for the web. And yeah, I've now been in open source real-time communication for over 10 years. And that's my Twitter/X and my Mastodon. NimbleApe, we're a real-time consultancy company based in the UK. And basically, you've got a hard problem when it comes to open media stuff, whether or not that's real-time or not, we can help you. And Everycast Labs, we're the creators of Broadcast Bridge, and Broadcast Bridge is a service for bringing remote talent into production AV workflows. So imagine we had a remote speaker that was actually live. Well, they'd use Broadcast Bridge, and then we'd hook into the AV team stuff over there, and we'd give them that feed in the format that they actually want it in, which is not what happens today. And then ComCon. Well, I don't need to talk about ComCon because you're here. So building iceperf.com. What is iceperf.com if you don't already know? Ice is vital for setting up a WebRTC session. Ice isn't just part of WebRTC. Ice is part of, it is its own thing. But a lot of us know about Ice because of WebRTC. It's how we make connections between WebRTC peers. When I say peers, a lot of people go, he's talking about a laptop and a phone. But we need to remember that a peer can be, a phone, but it can also be a server up in the cloud or in a data center. It's anything that is able to connect via WebRTC. And so ultimately, stun and turn are also vital. They're a pivotal part of the ICE process of how we connect to things. So what is stun? Stun, this is how I describe it to people. Stun is basically my client saying, oi, server up in the cloud somewhere, what's my public IP and what's the port that I can connect, that I connected via, etc., to be able to kind of poke through a firewall. And that's the point of stun. So what's turn? Turn is basically saying, oi, that same server, or maybe it's a different server, because they don't have to be the same. I want to send my traffic through you. How can I do that? And then you get back a stun, you get back an ICE candidate for whether or not it's a stun or a turn, server reflexive or relay. So ICE ultimately impacts how quickly we make WebRTC peer connections. It's absolutely pivotal. And so ultimately you can see why any delay in that ICE process can completely and utterly slow down how quickly a connection can get made. And you want your connection to be made as quickly as possible. So what public data is out there about the performance of these stun servers and these turn servers that we use? None. I mean, I did very, very little actual looking around, but in the 10 years that I've been kind of in this space, I've never seen any real data around, well, everyone uses the Google Stun server, and the Google Stun server replies with a candidate in this number of milliseconds. I've never seen that. And it's the same for all of these turn providers as well. So enter iceperf.com. It's spelled correctly now. So originally, iceperf started out as relayperf.com. The goal was to test turn networks. And ultimately, Who's the best turn network? Well, that's a really quite difficult question to answer, as it turns out. But after buying turnperf.com and relayperf.com, because I couldn't decide which one I wanted to use, we realized that that's only really half the story, right? So we went and bought iceperf.com. We didn't want to just test turn networks. We wanted to test ICE in general. So what does iceperf.com actually do, right? So firstly, the what. We test turn networks' abilities today. We want to do lots more in the future, as well as the Google Stun server, because everyone uses the Google Stun server. They shouldn't, but they do. I saw a document. What was it? It was a document or a demo or something from a proper provider the other day, and they have hard-coded the Google Stun server into their, even though they have a Stun server as part of their offering, they still went and hard-coded in Google Stun server into their code. So in the future, we test, today we test turn networks, and in the future, we want to test loads of open source projects as well. So the turn networks, I keep talking about turn networks. What are the turn networks? So first, who are they? So we've got Twilio and Xerxes. They've been around the longest. And then Cloudflare, Metered, and ExpressTurn. Cloudflare, Metered, and ExpressTurn are kind of the newbies to the group. Cloudflare's announcement, it's weird talking about this while we're in Cloudflare's office, but Cloudflare's announcement of creating a turn network prompted iceperf.com, because I was like, they've got like 300 points of presence all over the world. Like, if they're going to deploy this in 300 points of presence all over the world, then it should be really good, right? How do we test that? How do we know that it's actually any good? So, quick disclosure, I own Cloudflare shares, and I want Cloudflare to succeed. But that doesn't mean that I don't want everyone else to succeed as well. So, yeah, it's out there. I want people to look at the data and know what's behind it. So for a really, really long time, Twilio and Xerxes were the only proper entities at the party. And there really wasn't a lot of choice. And then a company called Subspace entered the race, and that was really great. But then they subsequently terminated operations, and that was really sad. They had plans to do really cool stuff, and they just ran out of money. So we ended up going back down to 2 real networks. But now we have 5, and that's really, really cool. So that's exciting, and ultimately it enables us to kind of go and do a load of testing. So today, iceperf.com tests 3 things. Time to receive a candidate, whether or not that's stun or whether or not that's turn. The latency through a turn server, and the throughput you can chuck through it as well. So these are all really important. If you take a long time to get your candidate, well, that's going to slow down how quickly you can set up your call. If your latency through your turn server is really long, is really high for some reason, well, that's going to slow down your data going through your application. Throughput through your turn server, well, this one's a little bit like, hey, we can look at big numbers, but it's still fairly important depending on the application that you're building. And the way that we do it is there's one process, and we use Pion for it. And there's one process, and it creates 2 peer connections. One of them is forced to use Relay, and one of them goes and gets a server-reflexive candidate. So those peer connections get started up with one ICE server, which is really different to how you would normally do it. Normally, you would go, right, here's my stun server, here's a turn server on UDP, here's a turn server on maybe TCP, but we might get rid of that entirely, and then here's a turn server on TLS. Because then it's going to go, right, I can connect via stun, I don't need to do this, or it's going to fail, 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 and it's going to eventually connect via turn. So normally you'd give like 3 or 4, but we are connecting with one. Because we want to test that one specific ICE server in our tests. As I said, tests force ICE transport policy of Relay, And then the way that we do it is we connect out to the turn server, and then it connects back to the second peer connection, and we put data through it. So all the tests are run through a home broadband connection. This is really important because cloud servers, if we went and ran it on a cloud server somewhere, well, we don't know what peering agreements are in place, and so we might get really good results. I mean, that's also true of my ISP. My ISP might have a really good peering agreement with, but ultimately that's a real life scenario, right? So how is it made? It's written in Go, and we use Pion. And it's as simple as calling iceperf with a config file. And it's BYOTSP. Marco made this. Bring your own turn server providers. I always forget. And so you plug in your providers, and then you can test them all. And then you can toggle providers on and off and their capabilities on and off with your config file. And you can start it up with different config files. Most important thing is everything is open source. So you can go and take a look at how we test things and go, Dan, you're looking at that stat wrong. And so we're able to go, no, like here's how we do it. And then all the data's out on the website. And then we're going to make all of the data available as well. So iceperf.com went live at JanusCon, which is probably 5 weeks ago, maybe. But there's loads still to do. Everything has a beginning. So what do we find? I've got 8 minutes left. What do we find? Oh, so yes, a disclaimer. So Cloudflare, Xersys, Metered, and Twilio have all given us credit. And so we don't pay anything for it, but then they don't give us a beneficial service for it. They just enable us to be able to go and do it without it costing a lot of money. ExpressTurn, we are on their free tier. So when you look at the results, remember, free tier. So latency. Latency. UDP, turn UDP, and these are from 5 or 6 weeks ago, and we're updating the website next week, hopefully with real-time data. But these are maybe not exact numbers as we would look at them today, but they're relative, right? So we can see that Cloudflare give us a candidate back within 19 milliseconds, whereas, say, Twilio, on average, this was 5-day average, and we run a test every single hour. So this is quite a bit of data, right? And so on average, Twilio was 43 milliseconds, whereas Cloudflare was 19. That's a big difference, right? And you can see the same again. TCP, 24 milliseconds, TLS, 24 milliseconds. These are just the tests again. So first ICE candidate, time to first ICE candidate, average time to receive first candidate. Yes, how quickly do we get back that candidate? You can see that, say, Xersys 43, Twilio 46, Metered 44, Google 75, and Cloudflare is a whopping 184. That's crazy. Like, that number is huge in comparison to everyone else. And this is a bit of an outlier. Google's Sun server is actually really, really, really good in comparison to everyone else's. So all of these stats are up on the website. I'm not going to go through them too much now, but ultimately Cloudflare do really quite well compared to everyone else. So what's a good example? Turn TLS, 66 megabits per second, whereas Metered, I think Metered at this time, no, this is the same result as we would get today, only gives you 1. Quick digression, did you know that you can just kind of create a turn URI if you think that the server's going to accept it? So Twilio, for example, doesn't give us back a TLS ICE server in their API. But if you go and make one, it works. So you can see here that the average time to receive the first candidate on Turn TLS on Twilio was 364, Cloudflare 190, Metered 326. But again, Cloudflare 17 megabits per second, whereas Twilio is only 10. Metered was at the 1 megabit per second again. And then we've got our throughput tests. Yeah, so all of these graphs are going on the website. They are already on the website. We're going to make them nice interactive graphs on the website. So yeah, you can see nice, oh, I can't see my mouse. You can see nice curves, right? Really high, like you get up to speed quickly and then it curves off. But don't rely on what they give you. So, that's in the wrong place. Where am I? This is the graph from 1 week before we launched iceperf.com. Sorry. If we go back, can you see that yellow line is a nice curve? And this was the result that we put live on the website. Do you see that same yellow line? So this was an issue with Cloudflare's turn server. And we shared preliminary data with Cloudflare. We would have done it for anyone else and gone, this looks a bit weird. And it was where we were, getting up to speed really, really quickly. And then they were what's the word I'm looking for? Trailing down, and they'd never stop. They'd never stop, like, until we stopped sending data, they would keep punishing us. And so they fixed it, and we ended up with nice, pretty graphs like that. So yes, iceperf.com has already helped fix an issue. Whether or not it would have all gone live like it, I don't know, but we helped. So what's next? I've got 3 minutes. Lots and lots and lots of things. So real-time access to the website. At the moment, it's all static data, but hopefully that's coming really soon. So we're going to add loads of more tests. So sending data, currently, sending media. Currently, we only send data. We send blocks of data via the data channel. But sending media is really quite different to sending blocks of data down a data channel. So we want to start sending media. We want to start measuring packet loss and max concurrent throughput, where we spin up 10, 20, 100 peer connections and go, how does this affect things? Separate locations for offerer and answerer. And this is really important when we talk about networks like Subspace we're doing, where your ingress and your egress were actually very different locations. And so all these things are really quite important. And API response times. What is the thing that you do every single time you go and create a peer connection? Well, you go and ask for a list of ICE servers from your provider. Well, if that response time from your provider is really long, well, that in itself is going to stop you from being able to set up your sessions really quickly as well. And then, well, what if Pion is doing something weird? Well, we want to test other libraries as well. And we want to do browser-based tests, and we want to do stuff from multiple locations in IPv6. IPv6 would just, happen if my ISP actually supported it. And loads more. So we're going to start adding expert analysis to each provider. Like at the moment, Twilio doesn't look as great as Cloudflare, but why would you go for Twilio instead of Cloudflare? They're already in loads of people's firewalls. And so Twilio turn servers work a lot, really, really well. So having that expert analysis at the top of each provider is really important. Cost analysis, like how much is it actually going to cost? For example, Cloudflare costs 5 cents per gigabyte. Twilio costs 40. Cloudflare only charge on the way out. Twilio charge on the way in and on the way out. You can see where all of these maths add up, right? So we want to start doing cost analysis as well. And testing open source projects. We've already started with RHEL from the Elixir WebRTC project, and adding in loads of WebRTC metrics, and like all of this results in loads and loads of data. So what are we going to do with all this data? Well, we're friends with GigaPipe, and we're friends with QXIP, who are behind QueryN, etc. So we're going to start working with GigaPipe. Well, we already have started. And that's part of how we're getting live data onto the website soon. Pushing all this data through a turn network. Oh, I'm over. Me. No, I'm not over. 29 seconds left. Pushing data through turn networks becomes really, really expensive, right? But thankfully, all of the turn providers are mostly on-side supporting us. But it's iceperf.com. We don't want to just stop with turn. So we're coming for CPaaS providers once we've done all of this work. Because, starting an ICE session up to a WebRTC CPaaS is exactly the same. So we're going to go for the CPaaS providers next. And how do we, productize it and make a little bit of money and better serve customers? So that's iceperf.com. Thank you very much. And if I very quickly, I've got, so this is our data from the last 6 hours. So if I just change this to the last 7 days. And so at the moment, we're pushing all of this up to the Grafana cloud, but we're in the process of moving over to Gigapipe. And then all of this data is going to become public as well. And then what else did I want to show you? Nothing. And you can go and do this today. That's the most important thing. You can go and run all these tests yourselves. You can go and test your own turn environment if you wanted to. It's really, really easy to go and do that. So that is me. Thank you very much.